Objective for today is to be able to factor these algebraic expressions, and then we're going to think of the greatest common factor to be able to do this. So let's just look at some of these examples together. So some of these, they do have the factor pointed out for us, but in others we're going to have to think of that ourselves, the GCF. So in this 8a plus 4, we already know that 4 is the GCF. So if I take out a 4 from this 8a plus 4, what would I have left over in parentheses if I factor out a 4? By show of a hand. Ava?
2a.
Yeah, so 2a will be my first addend, and then what would the second part be? Ava?
1.
1, exactly. So 2a plus 1 is the factored form of this 8a plus 4. And you can always check your work by multiplying. So 4 times 2a, that's 8a, and then 4 times 1, that's 4. Does everyone see how we got that?
Yep.
Question, Tommy?
2a.
What?
How do you get 2a?
So 2a is because we divided this 4, or you can think of it as dividing or factoring out this 4 from 8. So if you do 8a divided by 4, you get 2a. Does that make more sense? Alright, let's look at the second example. So 3.5m minus mn. So what is the greatest common factor between these two? Arun?
M.
M, exactly. So m is the only thing in common. So m would go in our parentheses, and then the second set of parentheses is already filled out as this 3.5 minus n. And like I said, you can always check your work. So if we multiplied m by 3.5, we would get back to this 3.5n minus m times n. Well, that's mn. Everyone see how that's the factored form? All right, let's try this second example, or the third one. So 14x plus 21. What is the GCF? Zad.
7x.
7x?
7.
7, exactly, because there's only one x on here, so we can't factor out an x, and we can't factor out a 7. So what would that leave me left over in my parentheses if I factor out a 7? Abby?
2x plus 3.
Good, yes, 2x plus 3. Alright, how about y minus xy? What is the greatest common factor between these? Brayden?
Wouldn't it be y?
Exactly, it would be y. So we take out a y, what would be left over in our parentheses? Austin?
X.
So x will be for the second one, right? If we take out a
So
y, what would we have for the first?
Y minus x.
Exactly, 1 minus x. Because y times 1 is y. That makes sense, everyone?
Yeah.
Alright, look at this last one. So we have 12a plus 16b minus 10c. So we're not going to factor out any variables because none of them are like terms. But what number can we factor out between 12, 16, and 10? C. Alright, Ava?
2.
2. Everyone agree that 2 is the GCF here?
Yeah.
Yes, it is. Alright, so if we take out a 2, what do I have left over in my parentheses?
6.
Arun?
6a plus 8b minus 5c.
6a plus 8b minus 5c. Exactly. Any questions on this so far? Tommy?
It's 6a.
6a came from dividing 12a by 2. So you can think of it as dividing it out or factoring it out. So see how we had 12a to start? If we take out a 2 or factor out a 2, that'll leave us 6a left over. Does that make sense?
Yeah.
Alright, any questions? Alright. So try this one. What is the factored form of this expression? So you guys can work on it for a minute by yourselves and then talk about it in your groups.
Okay.
Yeah, this one will go in your companions. I got it problem. Almost got here.
What factor goes into every single one of these numbers? 3. Yeah, so you would write that in parentheses. Then another parentheses, you would divide by 3, and then put the x next to it and put it in y. And put the answer to 2. So 4. Yeah, and then you do minus, because there's a minus. I got 3 times 4x minus 14y minus 6. Minus 1.
Minus 1.
Because we don't want to have a decimal.
Oh,
So for 3, we're not going to factor out 2. We're going to need to factor out 3 from all of these. Yes, GCF would be 3.
Wait, but that's why.
Because 3 goes into all of these numbers. 6 is too large.
Yeah, because
6 doesn't go in.
1 to 3 would be like
More exactly.
But when you're factoring, you want like a half.
Yeah.
I just because you can't factor 6 out of 3.
Okay.
So just this out.
Not quite, because this is taking out a 2 from these ones. You factored out 2. We have to factor out the same number for all.
You have to factor out a 3.
So,
Well, minus 1 is outside.
can I have a volunteer come up to the board for this one? I think I saw Aiden's hand first. So it's okay if you're still talking in your group. Aiden's gonna put up his answer for this one.
Write it large.
We'll see if we all agree. Looks good, thanks. All right, so Aiden factored out the 3, so the 3 was the GCF here. Do we all agree and have this down?
Yes.
All right, any questions on this? So I noticed some people, they wanted to maybe factor out a 2. Well, we want to keep whole numbers here. So make sure you're factoring where you're going to be left over with whole numbers. We don't want to deal with decimals or fractions. All right, let's move on to the next part. Okay, so here we're going to talk about like terms. Have you guys heard about the term like terms?
Yeah.
So that just means the terms are like, right? Is exactly what the word says. So here, some of these have like terms and some of them don't. So we're going to need to drag the ones that do, and then we can combine the like terms from there. So let's see. Can anyone point out one of these that has like terms in it, Phil?
7xy subtracted by 10xy.
Good. So there's one of ours with like terms. What's another one that has like terms on here? Owen?
12a plus ab.
I like that you said that. I agree that those have like terms because A is the like term, right? But in this example, they're focusing on the variables together. So for this one, it's not going to be one of our choices, even though I do agree that A is the like term there. So good point on that one. Brayden?
I would say n plus 6.25n.
Yeah, that's good. That's one of ours. All right, what's our last one with like terms, Ella?
Negative 5a plus 8a.
So now from here we can combine these. So if you guys want to write down these examples so you have them in your notebook. So if I have 7xy minus 10xy, if I combine these, what will I have as my answer, Abby?
So are we just doing the equation?
Yes.
Then negative 3xy.
Exactly, negative 3xy. Do we all see how she got that? Good. So n plus 6.25n. So remember that n has a 1 in front of it. We just can't see the 1. So what would that be, Phil, when we combine like terms?
Oh, I think it would be 7.25.
Yeah, exactly. So we're just adding 1. So 7.25n. Good job. All right, negative 5a plus 8a. When I combine like terms, what would I have, Saj?
3A?
Yes. Good job. 3a. Do we feel good about like terms and combining them?
Mm-hmm.
Yep. All right. So I believe there will be a problem for you guys to try. So see which expression has like terms and then combine the like terms when possible. So try this one in your groups and then we'll talk about it in a minute. No, because it's pretty quick.
Makes it negative 1, so basically
So keep talking in your groups. Ava's gonna come put this one up on the board for us.
Yes. Because whenever we talk about 3.5, we want 1n, so that's negative 1. So it's basically minus 1. You do.
Switch around with
All right, let's talk about this one together. So which expression has like terms? Well, it's just going to be this first one here because they both have the variable x. The second one does not have the same variable, so we cannot go any further with that second one. So Ava did a nice job putting this up for us. So negative x, or you could think of it as negative 1x plus 3.5x would be 2.5x. Everyone feel good about that? Thumbs up if you feel good. Understanding like terms? All right, good. So there's just one more part to talk about. We'll have some word problems in this section. So this is a got it problem, but let's talk about this one together and then you guys can do the second got it problem on your own. So the bakery manager at the grocery store decides to have a 15% off on all bread. So let's let B be the original price of a loaf of bread, and then we can use this expression, the B minus 0.15B, to find the new price of the loaf of bread. So if I wanted to write an equivalent expression by combining like terms, what would I have here? If I want to write an equivalent expression, so I'm going to factor out the letter B. Maisha.
So you would like pretend like there's a 1 in front of the D, and then when you'd add that or subtract that from 0.15b, you would get 0.85.
Yeah, exactly.
Yeah.
So just like what she just said, so we can think of this as a 1b. So if we do 1b minus 0.15b, we'll have 0.85b as our equivalent expression. Does everyone see where we got that? So this one, yeah, we were just combining like terms. We didn't have to factor anything out. But yeah, so we just subtract 1 minus 0.15b. So what does this tell us about the loaf of bread? What's this 0.85b representing? Nathan?
instead of being 100% original price or like the original price, it's since it's 15% off, it's only 85% of what the original price is.
Yeah, so I like how he said that. So that's exactly what we can think of here, or we can think of it as 0.85 times more the original price. That's our new price of bread. Does everyone see how to interpret that? Mm-hmm. All right, good job. So we'll try this last got it problem. and then we'll talk about it. So another word problem, and just see what you guys come up with in your groups. Definitely talk about this one together.
Yes, because 0.7
What do you guys think?
I said one thing I measured is so I said that because 30% off is how much you get off. So if you do like say it would cost $1, it would be $1 is how much you get off the price on this shirt because it's off not up. Yeah, you can find the sale price. The sale price. Find the sale price. 25 you get this how you do it. That's 30% of it. You find the part and you know what's the back. Yeah, sale price, straight to your price. The term is sale price. The term is using yeah, but multiply so like 0.7 basically means how much you're actually paying, and 0.3, which is 30%, are saying like how much you're getting off, and then 0.7 is like how much you're paying. So if you divide it by 0.3, you get how much you got off. Yeah, and you'd have to subtract that. Yeah.
Alright, let's talk about this one together. So a clothing store advertises a sale. Your friend says that you can find the sale price of a shirt by multiplying the shirt's original price by 0.7. Do you agree? And explain. Alright, Austin, what are you thinking?
Alright, so I think that I do agree. So basically you're taking 30% off all merchandise. So taking 30% off all merchandise means basically it's the sale price is 70% of the original price, because 70% plus 30% equals the whole, which is the original price.
Yes, exactly. I like how you said that. Good job. Does anyone else have anything else they want to add to that? Kunal?
Yes, because it says 30% off, not 30% of the sales price. So it's 70% of the sales price. So you multiply by 0.7.
Alright, so we do agree here. You can find the original price by multiplying by 0.7. Anyone else have anything else they want to add to this discussion? Alright, well, good job on the notes. So now we're going to move into an activity. If you guys just want to put your companions to the side or away real quick. And then if you could take out one whiteboard. I know there's multiple ones at each table, but let's just take out one. Alright, so everyone, we'll have our notebooks still, so we'll use our notebooks to write these. So in your groups, I want you guys to first, we're going to do 4 problems. This is the first one. First, try it on your own for 1 minute, so it'll be quiet in here while you guys are doing that. And then in your groups, you're going to discuss the final answer, and then as a group, you guys are going to decide what you want to put on your whiteboard, and that's what I'm going to check. So each round, we can rotate who writes on the whiteboard. So just have one person start, and then we'll move the whiteboard around so we each get a chance to write on the whiteboard. So first, we're